Okay, this is part 3 in my series of tests of this Ryobi power station. This is an 810 watt inrush load. It's 6 135 watt traffic signal lamps. And contact. And not a problem. Okay, so 6.85 amperes, 825 watts. 51% load, so we're good, but this is a resistive load. And this load is 4 55 watt compact fluorescent lamps and 2 42 watt compact fluorescent lamps. This is much of a test to see how accurate the power meter is or whether or not this thing will handle the inrush, because of some strange readings that I was getting with less than perfect loads at high levels with my welder testing yesterday, and that is being borne out right now because according to the power meter it says 19%, but these lamps, granted they're still starting up, are only drawing 238 watts, 239 watts, but 382 volt amperes, 384, 0.62 power factor, 3.15 amperes. So yeah, because I had a single few 100-watt grinder, and that reported this as being about 50% load, and the welder reported as being close to 100% load, even though it was only drawing about 1 to 1.1 kilowatts. Okay, 249 watts, and when the lamps reach steady state, I will resume the video because this can get kind of boring. And this is with 401 nameplate watts of lamps, 4 55 watts, 4 42 watts, and 1 13 watt lamp. Drawing right now 403 to 405 watts, bouncing around a bit. 610 volt amperes, and yet according to this thing, 33% load, which should be 528 watts. So it seems to be, with crappy power factors, the load meter on this power station reads somewhere between the actual power and the apparent power. And again, to represent somewhat realistic loads that most people are going to use with one of these things, I'm using compact fluorescent lamps, which have generally about 0.5, 0.6 power factor. Yeah, 0.66 according to this. Yeah, 409 watts now, 34%, which should be 544 watts. That's 413 watts, 624 VA. So yeah. For future reference, the load meter on this can be considered a rough guide at best. And now with all the lamps pretty much warmed up, it's 633 volt amperes, 418 watts, and it's claiming 35%, which should be 560 watts. So yeah, it's with a lot of somewhat realistic loads nowadays with, they're typically abominable power factors, at least from the standpoint of a power engineer. The power meter on this will read somewhere closer to the apparent power of a load as opposed to its real power. I mean, with a fully incandescent load, which you're probably not going to run off of one of these, it is pretty much bang on because it's getting 51% load with 825 watts. But yeah, so the meter on this isn't screamingly accurate, but depending on things, it is enough to tell you whether or not you're running close to overloading the thing with most loads. But yeah, especially high demand things at crappy power factors like welders, which I was doing yesterday, it is not going to be that accurate. Of course, it's also not going to be particularly happy, but again, for a lot of stuff, for emergency power things like refrigerators, because again, I've successfully ran a refrigerator and a chest freezer at the same time off of this thing. But yeah, so again, for emergency power, it works. And there goes its cooling fan. So yeah, if you need to keep a refrigerator running, this will work for a few hours. You can also charge stuff off of it because it does have USB-C and USB-A. So yeah, it works.